Hey there, future scientists! Today, we're diving into the mysterious world of electrons and their fancy footwork called the exchange interaction. So buckle up because things are about to get quantum. Alright, let's start with a bit of background. Electrons are tiny particles with a property called spin. They follow the rules of Fermi-Dirac statistics and the Pauli exclusion principle, which says no two electrons can occupy the same state at the same time. Sounds fancy, right? Now when you swap two electrons, the total wave function of the system must change sign. In other words, psi, 1, 2, equal sign, psi, 2, 1. To satisfy this rule, the spatial and spin parts of their wave functions are linked. If two electrons have parallel spins, they spatially avoid each other. If their spins are anti-parallel, they can be closer together. Why does this matter? Well, electrons with parallel spins reduce their spatial overlap, which lowers Coulomb repulsion and effectively lowers the energy. This energy difference is what we call exchange interaction energy. Let's break it down further. Imagine two identical kids in a room, representing our electrons. These kids don't want to be in the same spot and you can't tell them apart. If they spin the same way, they have to stay further apart. If they spin oppositely, they can be closer. This rule dictates their arrangement and results in different energy levels due to their spin orientation. So, where does this show up in real life? In magnetism, for example. In a magnet, millions of electrons align their spins the same way, lowering the overall energy thanks to exchange interaction. That's why materials like iron become magnetic, and let's not forget chemical bonds. The exchange interaction explains why certain bonds form and why electrons in atoms arrange themselves in specific ways. It's like a quantum game of musical chairs, where the rules dictate who sits where and how close they can be. In summary, exchange interaction is not a classical force. It's a quantum mechanical rule of arrangement that says, if you're alike and spin the same way, keep your distance. This results in an energy difference we call exchange interaction energy. So next time you think about electrons, remember, they're not just particles, they're dancers following the quantum choreography. Thanks for watching, and keep those minds curious. If you enjoyed this video, don't forget to like, subscribe, and hit that notification bell. Catch you in the next one.